And why? I don't think so. It is required to explain which one is preferable. Those apparatus measure minimum distance. Obviously, we can use this one. The screw is more convenient than Vernier Caliper. In what respect? Minimum thickness measurement. Class 9, be focused. Minimum thickness measurement. 0.001. This minimum distance we can measure with the help of screw gauge. So if you compare with the Vernier Caliper and screw gauge, which one you can prefer? Screw gauge. Reason you know. Okay. From this topic, from Vernier Caliper and screw gauge, one question will be coming in the competitive examination. That is, base is present in class 9. And this is again repeated in class 11 in practical, or class 12 also. When you do the meter bridge practical, at that time you can use the screw gauge to measurement the thickness of the wire. So these apparatus, total concept required to clear. If you don't know how to measure, how to operate, how can we operate the screw gauge or Vernier Caliper, you can suffer in class 9, in class 11 or in class 12. Understand the importance of the topic? Everyone understand the importance of the topic? Now our second target is how to calculate. How to, first you understand what is the importance of the apparatus? Why we choose this one? Reason you know, it is very much clear. Now the third question arises, how we can use this apparatus. How can measure the apparatus? What is the look of the, what is the diagram, what is the look of the apparatus? Sir, please. In detail I will explain here. Listen. This is the diagram of Vernier Caliper. This is the diagram of Vernier Caliper. Second name of Vernier Caliper is slide caliper. It is also said to be slide caliper. Why the name is given? Because in this apparatus there are two scales. In this class 9 we focus, okay, this is your base topic and this is your first chapter. In the first chapter this one is present. Okay, class 11 focus because you do the practical. Class 12 focus because you are going to attend the meter scale experiment in class 12 where it is required. Understand? To calculate the diameter of the bow, to calculate the volume of the sphere, and that time it is required. If you are understand now, then you can easily do the practical with the help of this apparatus. Now there are two scales. One, this one, that is called Vernier scale, and second one, this one, that is called main scale. This one is the main scale and this one is a Vernier scale. Vernier scale slide over the main scale, that is why it is said to be slide caliper. Clear? Vernier scale slide over main scale, that is why it is said to be slide caliper. Now, how many divisions are present in Vernier scale? How many divisions are present in Vernier scale? You can see these lines. There are 10 divisions. There are 10 divisions. There are 10 lines present in the Vernier scale, and there is no 1.1, 1.2, 1.3. There is a direct 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. There are only 10 divisions present in Vernier scale. But in main scale you can see, there is 0, then 1. In between 0 and 1, there are 10 divisions. After 1, there will be again 10 divisions. Then you 2. Then 1.1. After 1, the first line is 1.1. Second line 1.2. Third line 1.3. 1.4. 1.5. 1.9. Then 2. Again it are 2.1, 2.3, 2.4 and then 2.9, then 3. Understand? But this concept is not in the Vernier Caliper, Vernier scale. This is the only 1.1, 1.2. This counting number is only present in the main scale. In Vernier scale, there is no decimal place. Understood, everyone? After finishing my lecture, I will going to ask some question with you. So you will be prepared to give the answer. Okay? You can set your mind. Clear? If you have any doubt, again you can ask. No problem. But when I will be asked the question, you will be give the answer. Okay? So if you have any doubt, you can ask. Okay? This is the Vernier scale. How many divisions are present in the Vernier scale? How many divisions? There is no decimal. In main scale, there is 4, 4.1, 4.2 like. Okay? Now, Vernier constant. The word is coming Vernier constant. That is the most important things in this apparatus. Vernier constant. What is called Vernier constant? Acha, tell me one thing. What is called constant? You are very much familiar with the word constant.
Children, if we have biology class tomorrow, are you willing to come for the demo class tomorrow?
Honestly tell. If you come, then yes, then no, then no. Otherwise, we are confused.
So silence speaks. Only two. Silence saying yes. Not we. Only two. No, only. Not all.
Okay, listen. Then Vernier constant. Tell me what is the meaning of the word constant? Fixed value. Fixed value, no? This is called constant. If the same fixed value is repeated, that is called be constant. Here, in the Vernier scale, how many divisions again I ask? Very good. This is the first division, first line, first division, second line, second division. In between the first division and second division, the gap is there. The gap is there. Again you can see. First division, then second division. There will be gap in between the first and second division. Everyone see now? You know, this gap is said to be Vernier constant. This gap is said to be because this gap is present in Vernier scale now. So this gap is constant everywhere. So the name is given Vernier constant. Is it clear or not? Tell me everyone. What is Vernier constant, clear or not? In Vernier scale, there are 10 divisions. In each gap between the two divisions, that is the always constant value, and this constant value is said to be Vernier constant. Understand everyone? Understand everyone? Now our target is to calculate this Vernier constant. How we calculate the Vernier constant? How we calculate this Vernier constant? What is the procedure to calculate the Vernier constant? This is our next target. Before that, I want to ask something. Why we do the practical? Why we do the practical? You are doing the practical in class 11, right? You are also going to do the practical in class 12. In some in school class 9 practical is doing, class 10 practical doing. Tell me why we do the practical. For what is the main target, what is the main reason to introduce practical in our syllabus? Tell me. Yes, sir? Yes. And anyone? With a smile you can give the answer. Anyone? Whatever come in mind you can tell. No issue. Yes? For better understanding. Actually, yes. For better understanding or to understand the theoretical part. But you know, it is not possible. There are theory chapter. There are a lot of theory chapters are present. And each and every chapter practical is not present. That is the fact. That you can see, or you can already see that. Okay. Actually, the reason is to get the accurate value, to measurement accuracy. Yes, I am right or wrong? To measure anything in accurate way, we do the practical. That is why we use the Vernier Caliper. Otherwise, what is required the Vernier Caliper? We can measure anything with the help of scale. But reason is we want to know the accurate value. That is why we do the practical. There is one question from my side. I have given one comment on this topic. Why? What type of comment I want to do? Tell me, and you already know, class you are 12 now? You are also 12, you are also 12. You are also 12. Acha. And you are coming in class 11, right? So in class 10 you are studying the chapter machine. You are also familiar with the chapter machine. Class 9 students, please tell me, you know the chapter machine? 100% you know below classes you know the machine, lever, first class lever, second. How do you say this? You don't know about the machine? First class lever, second class lever, you don't know? Yeah, acha, very good. That means you know the chapter machine. Acha. There is my one question. Is it possible any machine without any error? Is it possible to make any machine that is ideal? Ideal machine is exist in nature? No. Ideal machine is not exist in nature. Why? Because
of energy loss.
Energy loss and energy loss and very good. And other point, friction. Very good. Friction, that is why the energy loss. Friction, that is why energy losses. Actually, my dear, the main problem of the machine is some error is present in the machine. Some error present in machine. Some error is present in machine, that is why it is not be an ideal. That is the reason its efficiency is not 100%. Some error is present in the machine. Now my dear, tell me one thing. You use the machine to measure anything and this machine is already having an error. Then how your observation, your calculation is error free? Tell me. We use the machine now to measure anything and we already know that a machine is not free from error. So already an error is present in the machine and this machine we can use to measure the accurate value. Then error will be present now. That is, and we can't rectify. We can't rectify any machine. We can't rectify. We not prepare any kind of machine which is error free. That is why now you tell this the efficiency is not 100%. We are not able to prepare any kind of machine which is error free or ideal machine. Then error, you can measure anything, then some error will be present in your answer. Now, what we do? We are in class 11, when you are class 9 students, when you are past class 10, when you reach in class 11, or those who are class 12 already they know, those who are class 11 they are willing to know. Okay, we are calculate the error. We understand there is a one topic. The topic is given how to calculate the error. How to calculate the error. Because we are unable to rectify the apparatus. We can't remove the error from the instrument. Then how this error will be removed? How we get the accurate value? To get the accurate value, some concept, some topic are present in class 11. That is error calculation. By the help of this topic, by understanding this topic, we can calculate any reading, any calculation error free. Clear? Now this topic is clear. Now I am back to the Vernier Caliper main topic. In Vernier Caliper, there will be some error present. As you know, what kind of error is present in the Vernier Caliper? There are two types of error. One is positive error and one is negative error. Clear? Those are class 9, those already passed and is converted to class 10. They already well know about the positive and negative. Those are in class 9. They are next. Your topic will be just explain you how the positive and negative error will be calculated. The positive and negative error. There are two type of error. Positive and negative. Class 11 it is required, class 12 it is also required. So all of the students must focus on this topic. How to calculate the positive error, how to calculate the negative error. Before that, before calculation, our target is to understand how we understand this is the positive error, this is the negative error. First of all, you understand now by C the apparatus you can understand this is the positive or negative error. Then the target is to calculate the positive or negative error. Okay, now we are focused how to understand which one is positive, which one is the negative error. See this one. This upper line is the Vernier scale. This lower line is the Vernier scale. See how many lines is the Vernier scale? 0, 1, and 1, 10. So how many lines in the Vernier scale? 10. This is the upper one is the Vernier scale. Tell me one thing. The 0 that is present in Vernier scale and there are 2 0. 1 0 in Vernier scale, 1 0 in Vernier scale. Tell me, Vernier scale 0 is exceed from main scale 0. It is visible to all. It is visible to all. Vernier scale 0 is exceed than main scale 0. Exceed what when we use? Positive sense. So if the Vernier scale 0 is exceed from the main scale, it is said to be positive error. It is said to be. Everyone understand? Everyone understand? How can we by watching how do we understand this is called positive or negative error? Now tell me, if it is negative error, how does it look like? Vernier scale 0, main scale 0 is exceed, then Vernier scale 0, then is said to be negative error. Understand everyone? So by C the apparatus, if I give you the one apparatus in your hand, then by C the apparatus, you can understand now my apparatus is positive error, give the positive error or negative error. Clear or not? Clear or not? If your 0 in the Vernier scale and 0 in the main scale both are coincide in the same position, then what you say? Then what you say? If your Vernier scale 0 or your main scale 0 both are coincide in the same position, there is no up and down, then what you say? Your apparatus is error free. There are no 0 error in your apparatus. Understand my dear? So if 0 0 coincide, then it is not positive, not negative, then it is no 0 error. Okay? If Vernier caliper 0 exceed, positive. If Vernier caliper scale is back and main scale 0 is exceed, then negative error. Clear? Understand everyone? Now, our target is to calculate the. Everyone having copy now? Copy of pen now? Yes. Give the little bit heavy. Give the heading Vernier caliper and give the 2 marks positive error and negative error. Yes, first ask for the. Okay, listen here. This one exceed, little bit exceed, but this is positive error. See this one. Don't see this one. Okay, this Vernier Caliper 0 is exceed than Vernier scale 0. It is negative error. Now our target is how to calculate the positive or negative 0 error. Okay. Now see, in Vernier scale there are 10 divisions. Which number of division in Vernier scale exactly coincide with main scale reading? Which number mean to say what? First number, second number, third number, fourth, fifth, sixth, seventh, eighth, ninth, 10. So in Vernier scale there are 10 lines. So which number of line is exactly coincide? Coincide mean to say exactly mean to say like just like this. This is the Vernier scale reading. This is the main scale line. So which number of Vernier scale reading exactly coincide with the main scale? Like this, not like this, not like this. Exactly coincide. Which number of Vernier scale division? You can see and tell me from here. 4. Okay, 4. This is the 0, this is the 1. 1 is not coincide. 1 is not coincide. There is a gap. 2. There is also gap. 3. 4th number line you can see. 4th number line in the Vernier scale you can see. This is exactly coincide. It is not like a different line. It is just look like a single line. This single line we have to identify. So which line is exactly coincide? So 4 number lines. It is not 1.1, 2.2, 1.2, yeah 1.4. It is only 4. It is only 4. Always keep in mind the Vernier scale reading is not in decimal. It will be always in whole number. Clear? So 4 number line coincide. This is called Vernier scale reading. This is called Acha. This is called Vernier scale reading. So your Vernier scale reading is 4. Clear? Now to calculate the positive error, write the formula. Write down the formula. Positive error equal to minimize again program. Okay, class, please, give me one class. How can I get listen. Positive error. Write down the formula. Plus, first of all, it is the plus. Then Vernier scale reading into Vernier constant. VSR full form Vernier scale reading और V dot C Vernier constant. Clear? अच्छा. Tell me one thing. You see the positive error. Which number coincide? 4. The Vernier scale reading is 4. Plus 4 into Vernier constant is fixed in the Vernier caliper. Later I will explain how the values come. It is 0.01. अच्छा, in centimeter or millimeter? Centimeter, millimeter? In centimeter. In millimeter, 0.1. In millimeter, what is the Vernier constant value? 0.1 millimeter. When you convert in centimeter, 0.01 centimeter. Clear? Now tell me your answer.
Plus 0.04.
Plus 0.04. This is centimeter. This is your positive error. Understand how to calculate the positive error? Class 9 is understand?
Yes.
Class 11 understand? Class 12? Okay? This is the way out to calculate the positive error in the Vernier scale. Okay? Now, negative error in the Vernier caliper, how we calculate? See the picture of negative error. See the picture negative error. This main scale 0 is exceed that Vernier scale 0. Now we understand this is the negative error. Now again you same things you can search. Which reading is exactly coincide? 8. Which reading is exactly coincide? 8. So what is our Vernier scale reading? 8 is our Vernier scale reading. Clear? 8. Now write down the working formula to calculate the negative error. Write down the working formula. I will only tell the formula, but you will calculate and tell me what is the answer. Write down negative error in Vernier caliper equal to. First of all, negative error now you give the minus sign. Minus, then first bracket. Wait, tell me how many lines in the Vernier scale? Fix now. Write 10. Minus, then Vernier scale reading. Write down Vernier scale reading. Vernier scale. First of all minus, then first bracket, then 10 minus Vernier scale reading, then bracket close. Into. After closing the bracket, you give the into V dot C, Vernier constant. Vernier constant, V dot C. Again I repeat, minus, then first bracket, 10 minus Vernier scale reading, then bracket close. After closing the bracket, then again give the multiply sign and write V dot C, yani Vernier constant. Clear? Now tell me. Now you will calculate and tell me the answer. Minus first bracket 10 minus 8. 8 is your Vernier scale reading now. 8 is your Vernier scale reading. Then bracket close. Then multiply with Vernier constant. What is the value of Vernier constant? 0.01. Then put and calculate. Minus. This is the negative error value. This one is the negative error. Clear or not, everyone? Everyone understand? Anyone? Last page. Concentrate. Anyone having any doubt? Anyone having any doubt? Any confusion? No confusion? Yes. Because in Vernier scale how many lines? 10 fixed. So 10 minus. No. In positive error we don't require minus. Only the format is for negative error. Okay. In positive error only Vernier scale reading plus Vernier scale reading into Vernier constant. But at the time of calculating the negative error, then minus first bracket and how many divisions the Vernier scale 10? Then 10 minus Vernier scale reading, close the bracket, then Vernier constant. This is the fixed process. Okay? Understand everyone? Now, listen. With the help of Vernier caliper, you can measure the thickness. With the help of Vernier caliper, you measure the thickness. You use the formula to calculate the thickness of the any apparatus, any object. You can calculate according to formula. You calculate the reading. Now the question is asking what is the correct value. Correct value means to say those you are calculate now. Those you are calculate the value, this is not a correct value because some error is present, and that is why we can calculate the positive error or negative error. After calculating this error, then you can minus with your actual value. Then your answer is accurate value, accurate answer. Clear? So that is the reason we can calculate the error, positive or negative from the apparatus. Okay, I will explain how it is, how we can calculate the normal or actual value from the Vernier caliper. Okay.
Yes.
Normal format to calculate the thickness of a body for the Vernier caliper. You write the formula: thickness or length equal to main scale reading plus Vernier scale reading into Vernier constant. This is the format. This is the format. With the help of this format, you can calculate the diameter or any length. Okay. After then, you can see the apparatus which error is present. Okay. Then your correct value will be calculated by equal to this diameter whatever you get minus that error you can calculate now, positive error or negative error whatever you given, you can write over here error. You're using this formula, you can calculate the first of all value, then you can calculate the error, whatever it is positive or negative, it is depend on your apparatus in which error is present. Then after calculating the error, then you can minus it. Then in this way you can calculate the correct value. Understand? Now our target is how to calculate this value. How we identify where is the main scale, where is the Vernier scale, where is the Vernier constant. One example I see. You write the formula? Okay. Okay, listen. See this picture. See this picture. Okay. Here we can calculate the diameter of thickness. Anything. There are. This is the Vernier scale. How many lines? 10 lines. This is the main scale. Okay. Vernier scale. First reading, that is 0. This one now. Acha. This is matched with. There is a 4. That means previous one is 3. Clear? So after 3.9, there it is gonna 4. So tell me which one is this reading? Anyone? What is the value of this reading? 3 points? Is this? 3.7, 3.8, 3.9, then 4. Then we get, this value, this 0 of the Vernier scale come in between these two lines now. Then we can accept previous one. If it is in this situation now, then always you can prepare the previous reading. Okay, don't follow the second one. You can follow the previous one. Then your main scale reading. You get the format now, D equal to MSD, ASR plus VSR into V dot C. Okay, what is the MS value? MSR reading, main scale reading. That is 3.7 this one now. This is 3.8, but we can consider only 3.7 right now. MSR equal to 3.7. MSR equal to 3.7. Now tell me, which line is exactly one side? Which one is the Vernier scale reading? Everyone, no one can tell. Okay, you can only keep your mind. I will ask the question. With anyone, you can just see the picture and tell me which one is Vernier scale reading. Ask you. Shut up. Yes. Tell me which line in between the 10. Which line is exactly one side? 4. 4 is in the one side. See? 4 is not one side. Sit down. Class bench. You. Yes. 3. Everyone familiar with? Everyone? 3 or 4? 3. Now it is clear? See? This is exactly matched. This is just look like a single line. Okay? This is one side. Then what is your Vernier scale reading? 3. Write down VSR equal to 3. VSR equal to 3. Got everyone? Now, V dot C value is fixed. What is the value? 0.01. Now calculate what is the value of D. 3 point? 3 point? Now class 9, please calculate. Last bench, all of you calculate. In this way, you can calculate the diameter or thickness of any body, anything, any object. If apparatus having error, either positive or negative, the process already you know, I already explained. Then this 3 point, whatever the values come, minus your error, then your answer is accurate. Clear? Everyone understand this concept? Everyone? Now, most important things I am going to discuss, how to calculate the Vernier constant. Because from starting to till, we only write the value 0.01. I am not explain how these values come. Now I am going to discuss. Here up to this point, everything is clear? Everyone, class 9 especially tell me, it is clear? Are you understand? If you have any doubt, again you can ask with me.
Sir, we need this Vernier constant as least count.
Least count or Vernier constant? Actually, both are in the sum book it is taken as same. But I will tell you, least count you can use in the screw gauge or Vernier constant you can use in the Vernier caliper. It is better. Otherwise, in the most of the book, least count, Vernier constant both are taken the same way. Okay. Now we are going to discuss how we calculate the Vernier constant. Vernier constant. Tell me one thing. If there is no object is placed in the apparatus, you can touch the job. 2 lines you can touch. Okay. Then you see the 10 number of Vernier scale division exactly match with 9 number of main scale division. If you want to see the picture, again you can see how it look like. Vernier constant diagram. Vernier constant diagram. Vernier constant. Now listen, see this picture. This is the Vernier scale and upper one is main scale. Okay? See, when there is no object, J1 and J2 is touched. Because in between J1 and J2 we can keep any object that we want to measure the thickness or diameter. Okay? But here no object, we can touch J1 and J2. Now tell me, 10 number of Vernier scale division match with which division of main scale? How many divisions of main scale? This 10 number division of the Vernier scale is coincide with previous one now, because that's why. See, this 10 number division of the Vernier scale, okay, not exactly match with 1. See, it is not exactly 1, match with 1. Between 0 to 1, how many lines? 10 lines. If it is not match with 1, then it is match with previous one, that is 9. That is 9. 10 number of Vernier scale division match with 9 number of main scale division. Are you understand this point? See again, 10 number of division of Vernier scale match with 9 number division of main scale. Why we consider 9? Again I tell. This is the 1. When you say total 10 number division, but it is in between 9 and 10. Then what I am saying? Always you take the previous one. If your value is come under in between the 2 1, then you can always consider previous one. Then you can consider 9, right? So 10 number division of Vernier scale match with 9 number division of main scale. Are you understand my point? In the diagram you can understand? Okay. Now back to calculate. What we write? How we write? 10 Vernier scale division match with 9 number of main scale division. Right? Now tell me, 1 Vernier scale division equal to 9 by 10 main scale division. Now, process to calculate the Vernier constant, we use the formula. 1 Vernier constant equal to 1 main scale division minus 1 Vernier scale division. Okay? In 1 main scale division you can write the same one, MSD minus. At the place of 1 VSD, what is the value you get?
9 by 10.
1 VSD equal to 9 by 10? Right. 9 by 10 MSD. Now tell me, do the minus. 10 minus 10, 10 minus 9, that is 1 by 10 MSD. Right? 1 by 10 mean to say 0.1, that is in millimeter. If you convert it to centimeter, 0.01 centimeter. Clear or not? Clear everyone? In this way we can calculate the Vernier constant. Achha. Now I will come to the main topic. In competitive examination, especially in the Neet examination, you can go and search the paper. Sometime here it will be changed. So some changes will be doing this position. 10 Vernier scale division equal to 9 Vernier scale division. They will give their own numerical value. They will say if this value is matched with this value, then calculate the diameter or calculate the value of this one. Either calculate the volume, anything, but you require the thickness now. For calculation the thickness, what we require? Vernier constant, main scale reading, or Vernier scale. Three things will be required to calculation of anything. Suppose you want to calculate the volume of the spherical ball. Calculate the volume of this sphere. If you want to calculate the volume of this sphere, so what is the formula of volume of this sphere? 4 pi r square or 4 by 3 pi r cube?
4 by 3 by r cube.
4 by 3 pi r cube. What is the value of pi? 3.14. Okay. The value of r you can calculate radius, but with the help of Vernier caliper, you don't direct you never calculate the radius directly. You calculate the diameter, and for the diameter format already I given, and one example also you do. Okay? Then we calculate the diameter. Suppose whatever the diameter you get, you can calculate the radius from here r equal to d by 2. You can easily calculate the radius. After getting the value of r, you can substitute the value here and get the value of volume. Then the question is given like this. This is the one of the kind of example I am given. Calculate the volume. In the competitive exam, they will ask the question, calculate the anything, area of cross section or volume of the body, but procedure is same. Here you use the diameter formula. You can in diameter formula you see what is the formula? Main scale reading plus Vernier scale reading into Vernier constant. You always keep the information in mind. Vernier constant meant to say 0.01, but this situation will be changed. Here they do the changes in the competitive exam. Here they will say 50 Vernier scale division equal to 49 Vernier scale division. Then calculate the volume of the sphere. Then first of all, these all are changed. Your Vernier constant reading will be changed. This Vernier scale reading you can use in the formula D. Then calculate. This is the question. Clear? That is why I select such kind of topic that is present in class 9, that is present in class 11, practical, and that is also present in class 12 in competitive. I hope so everyone understand. If the question is given 50 Vernier scale division coincide with 49 Vernier scale division, then what is the Vernier constant? Tell me. Single. Wait. This is 49. Then 1 PhD equal to 49 by 50 MSD. Then here it will be changed. Minus, tell me, 49 divided by 50. What is the answer here? 1 by 50. 1 by 50. What is your answer? 1 by 50. Tell me. 1 by 50 equal to 0.02 millimeter or centimeter? If you convert in centimeter, 0.002. Whatever the reading is from, that is convert करना. This is the procedure. Now this value you can use to calculate the whatever the body is given and their volume or area of cross-section is calculated. This is the important question. I hope so. Regarding Vernier caliper, everything is clear. But by diagram, by watching, how can one understand? How you identify the nature of error, positive or negative, how to calculate the positive error, negative error, how the question will become, some diagram will be given. Class 9 you can see, some diagram will be given in the exam. Our question is asking, calculate the either Vernier constant, calculate the diameter or calculate the radius, whatever. But picture will be given. So easily I think so you are able to attend the question in class 9. Class 11, in practical examination, this diagram will be given and the question will be asked. And sometimes the bob is given or any wire is given. If the wire is given, then your question will be calculate the length, not area of cross-section. For the area of cross-section, we use the screw gauge. That is the different one apparatus. Their process is also different. Okay, I hope so everyone understand this one. I can stop the topic. Okay, if you get the chance, then you can next class. I will start screw gauge in detail. After then, one question at least you can attend in the exam, competitive exam. Okay, thank you so much. I hope so everyone understand.